Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed one of the process synchronization mechanism which is a lock variable in detail, and then I have discussed the limitations in the lock variable. I hope you have watched that video. If you did not watch that video or if you don't know that concept, I request you to go back and watch that video and come back to this video. In this video, I want to discuss about one more process synchronization mechanism which is test and set instruction in detail. So I request everyone to watch the complete video for better understanding. Before discussing about the test and set instruction, let me give an overview about the lock variable and what is the limitation of it, and that limitation how we overcome in the test and set I will discuss. Okay, so when it comes to the lock variable, we have a lock variable. Initially we have initialize the local variable as 0. Now if the lock variable is equal to 0, meaning is that the critical session is vacant. If lock variable is equal to 1, the critical session is occupied. Okay, so initially lock variable is equal to 0, and we know that we will have a entry session, then critical session and exit session. So now let me write the code for the entry session. While lock not equal to 0 ends with a semicolon, lock is equal to 1. This is the entry session. Okay, and then you will have the critical section, and then you will have the exit session. Lock is equal to 0. So this is the entry session and exit session for the lock variable. Now look at here how it will work. The lock variable can work for more than two processes also, but for better understanding, let me take only two processes such as P1 and P2. Now initially lock variable is equal to 0. Now look at here, process P1 wants to enter to the critical session. Then first it has to execute the entry session. So what it will do, it will check this condition while lock not equal to 0. What is the lock variable? Lock variable is equal to 0. They are saying 0 not equal to 0. But what is the true? 0 is equal to 0. So this condition is false. If this condition is false, it will execute this instruction. Let me write the number. This is instruction 1, this is instruction 2, this is critical session. Let me write it as instruction 3, and this is instruction 4. Now process P1 has executed the instruction 1. Now the condition is false. If this condition is false, the process P1 can execute the instruction 2. Before it has to execute the instruction 2, process P1 was preempted. Okay, process P1 was preempted. So in the program counter, it will have the address of this instruction. Is it clear? Are you able to understand? Now process P2 wants to enter the critical session. Again, the process P2 also should execute the instruction 1, instruction 2, then only it can execute the instruction 3, then only it can execute the instruction 4. So look at here, process P1 after executing this first instruction, it was about to change the lock variable as to 1, it was preempted. So still the lock variable value is equal to 0. So again process P2 will execute the instruction 1. If it executes the instruction 1, it will found that this condition is false because 0 not equal to 0. They are saying, however, 0 is equal to 0. So this condition is false. If this condition is false, process P2 can also execute the instruction 2. If it executes the instruction 2, lock variable value will becomes 1. Is it clear? Then process P2 can execute the instruction 3. Is it clear? So meaning is that right now process P2 is in the critical session. Let's consider this is the critical session. Now process P2 is in the critical session. Now let's take that process P1 has been scheduled. Okay, process P1 has been scheduled again, meaning is that it came from the ready state to the running state. Now which instruction it will execute? It will execute the instruction 2 because it will have the address of this instruction in the program counter. So what is it? Lock is equal to 1. already lock value is equal to 1, again it will keep the lock value is equal to 1. So process P1 also executed the instruction 2, then it will also execute the critical session. So meaning is that process P1 also enter into the critical session. So what is happening? Mutual exclusion is not provided using the lock variable. Why? In critical session, at a time only one process can be there, but in this situation two processes are there, so mutual exclusion is not provided. Mutual exclusion is one of the important parameter any process synchronization mechanism should provide, but however lock variable process synchronization mechanism is not able to provide it. Why this issue came? Here it is testing whether lock not equal to 0 or not, it is testing, and here it is setting the value lock is equal to 1. Before the set, it was preempted, the process P1 was preempted, then only this issue came. So let's consider this is the test and this is a set. Between test and set, if there will be a preemption, then mutual exclusion is not provided. Okay, so they have understood the limitation that between test and set, if we allow the preemption, then this problem will come. So what they have done is that they have modified and provided test and set instruction. It is a separate instruction your hardware should support. Is it clear? Are you able to understand it or not? So how it will work is that, let me discuss about the test and set instruction. I hope you have understood the limitation in the lock variable and why that limitation came. Now how it will be overcome in this one, I will discuss for you. Let me erase this concept. Okay, now look at here. While this is your entry session, because any critical section or the synchronization mechanism should have the entry session and exit session, okay, and you will have the critical session. Now look at here. While test and set is a function, okay, and the function is having one parameter which is an address of the lock variable. So look at here. Here also we will use the lock variable. Okay, lock variable initially we know that it is 0. Is it clear? If it is 0, meaning is that critical session is vacant. If it is 1, critical session is occupied. Okay, in Boolean 0 we will represent it as false. Is it clear? 1 is equal to true, so lock is equal to false initial condition. Now look at here. While test and set, you are giving the address of the variable called lock. Okay, let me keep it a small l, otherwise you will think that both are different variables. Okay, now look at here. When let's take that process P1 and process P2 is there. Let me take it two process. Now process P1 wants to enter into the critical session. If process P1 wants to enter into the critical session, then it has to execute the entry section. Okay, so let's take it. It is executing the entry session while test and set ampersand lock. So it will go to the function definition. This is your function definition. Okay, now look at here. Boolean test and set Boolean target. So the meaning is that this function is passing a or returning a Boolean variable. Is it clear? Are you able to understand? Because any function will have the return type, function name and list of parameters. And look at here. As this lock variable is storing either true or false, we can consider it as a Boolean variable. So a Boolean variable address can be stored by a Boolean pointer only. Is it clear? I hope you are able to understand why I have written the data type of the target as Boolean. Is it clear? So look at here. Let's consider that you have a lock variable. Okay, its initial value is false. Okay, it's there in the address 100. Okay, let us consider that this variable is there in the address location 100. Now what is the meaning of this one? You have a pointer called target. Okay, is it clear? This is small t, otherwise again you will confuse. Okay, then what it will do, it will store the address of this lock variable. What is the address of the lock variable? 100. Let's consider that this target variable is there in the address location 200. Is it clear? So you have the address of the lock variable in the target pointer. Now look at here, boolean s is equal to star target. So you have another variable called s. I hope it is visible for you. Okay. If it is not visible, let me reduce it. Okay. So now look at here, boolean s is equal to star target. What is our target? Is consists of address, which is 100. So you will go to the address location 100 and what value it is there, false. So that value will be stored in this variable called s. I hope it is clear for you. Now look at here, star target is equal to true. Star target, what is a target? Is consists of 100. You go to the 100 location. Okay, there you need to store the value true. So previously here it is false, now it is updating to true. Okay, now return yes. Is it clear? Are you able to understand? Return yes. What it will return? False. So here you are getting the false. Okay, now look at here, already I have discussed in the lock variable. Now while false, if this condition is false, as there is a semicolon, it will execute the critical session. If its value returns the value called true, is it clear? Here if the condition is true, then it will go to the infinite loop, because meaning is that again it will check the condition. If this condition is false, it will execute the critical session. As it returns the value false, so meaning is that this condition is false. Is it clear? If this condition is false, as there is a semicolon, it will enter into the critical session. So process P1, let's keep it this as 1 and this is 2, this is 3. Now look at here, it is executed the instruction 1 and it has executed the instruction 2, meaning is that in critical session process P1 is there. Are you able to follow with me or not? Okay, now critical session process P1 is there. Now look at here, process P2 wants to enter into the critical session. Is it clear? It is trying to enter into the critical session. What will happen? Now look at here. Now again process P2 has to execute the entry session. So while it will go to the function definition of test and set. Okay, now look at here, boolean star target. Is it clear? What is the lock variable value now? Lock value is consists of true. Is it clear? Because it is passing the address of the lock variable, which is true. So here you will get the value true. Is it clear? Are you able to understand? Because it has updated. Are you able to understand? Process P1 has tested and set the value to true. So and it entered to the critical session. Now lock variable is having the value true. So now look at here. Boolean s is equal to star target. What is the target? Is consists of 100. So it will go to the 100 location. Okay, what value is there? True. That value you need to store in the boolean variable called s. So here in place of false, you will get the value as true. Are you able to understand? Now star target is equal to true. Star target, you will go to the 100 location. Is it clear? And you will keep the value here true. So star target is equal to true. That is correct. Okay, already true is there, you are keeping again true, no problem. Now return yes, you are returning the true. So here you will get the return value as true. Is it clear? If this value is true, what is the meaning? As there is a semicolon, again it will test the condition. So it process P2 is going to the infinite loop, meaning is that it is waiting. It is still there in the entry session. It will keep on checking this condition. So it is doing the busy waiting. Already I have discussed that process synchronization mechanisms are broadly classified into two types. One is busy waiting and non-busy waiting. And this test and set instruction comes in the category called busy waiting, because process P2 is keep on executing the entry section only. Now look at here. When the process P1 comes out from the critical session, then it will execute the instruction called lock is equal to false. Is it clear? Now lock variable value becomes false. Are you able to understand? So meaning is that process P1 has come out from the critical session. Okay, are you able to get it or not? Now look at here. If process P1 comes out from the critical session, now critical session is vacant. Can the process P2 enter into the critical session or not? We will check it. Now lock value is equal to false. So if process P2 wants to execute the entry session, because it wants to go to the critical session, it has to execute the critical entry session. So again it will execute these three steps. So boolean s is equal to star target. Target is having the value 100, so it will go to the address location 100 and it will get the value false. That value you are storing in a boolean variable called s. So s is consists of value called false. Okay, now star target is equal to true. So target is having the address 100, go to the 100th location and set the value as true. So already the value is false, now you are setting it as true. Now return yes. So what is the value is there in the boolean variable? Yes, false. So you will get the value here it as false. Is it clear? So if this condition is false, then you can enter into the critical session. Now process P2 will enter into the critical session. So if you look at clearly, at a time only one process is able to go to the critical session. Okay, are you able to understand? So mutual exclusion is provided. Okay, so that is the first requirement for any process synchronization mechanism. So test and set instruction is able to provide the mutual exclusion. Let me write it. The primary requirements and the secondary requirements. The primary requirement is mutual exclusion. Test and set instruction is able to provide the mutual exclusion. And the second requirement is progress. Now let me check it whether progress is achieved or not. Okay, now look at here. When process P1 is not entering into the critical session, meaning is that lock value will be false. Is it clear? Are you able to understand? Initial value is lock value is false. If process P1 does not want to enter into the critical session, then it will not execute the entry session. Am I right or wrong? So if the process P1 is not executing and process P2 wants to enter into the critical session, process P2 can successfully enter into the critical session. If you have a doubt, you can execute the same code again and you can check it. Lock value is equal to initially false. So here you will get the value as false and you process P2 can execute that part. You can check it. Okay, is it clear? Are you able to understand? So what I want to say is that if process P1 does not want to enter into the critical session, process P2 can enter. What is the meaning of progress? If one process does not want to enter into the critical session, it should not stop other process to enter into the critical session. It is not like that I don't want to work and I should not allow you to also not to work. Then there is no progress. You are not working and I am also not working. But progress meaning is that if process P1 does not want to enter into the critical session, it should allow the process P2 to enter into the critical session. Then only progress can be achieved. In test and set instruction, if one process does not want to enter into the critical section, it will allow the other process to enter into the critical session. So even progress is achieved. Now let me discuss about the secondary requirements of any process synchronization mechanism. The two secondary requirements are, one is the bounded wait. Okay, meaning is that there should be no starvation. Bounded wait. And the next one is the portability. Are you able to understand it or not? Now let me discuss whether bounded wait can be achieved or not. Look at here. Let me take a simple example. Let's take that process P1 is there, process P2 is there. Okay. Now let's consider that process P2 enter into the critical session. Is it clear? Using the test and set instruction. I'm talking about the test and set instruction only. Process P1 has entered into the critical session. Now what the process P2 will do? It will be in busy waiting. Am I right or wrong? Is it clear? Are you able to understand it or not? So process P1 has entered into the critical session and it was preempted. Now process P2 tries to enter into the critical session, but it will not allow. It is in the busy waiting. Are you able to understand? It is not like it is in the wait state. Don't get confused with both the things. It is keep on checking this entry session only. Okay, now process P2 was preempted and then process P1 again come back in the running state. Now process P1 will complete its critical session and it will execute the exit part also, meaning is that process P1 is come out from the critical session. Now critical session is vacant. By that time process P3 was scheduled. Process P2 was is in the ready queue, but process P3 was scheduled. Now if process P3 is scheduled and it wants to enter into the critical session, process P3 will enter into the critical session. Is it clear? And it was preempted. Now process P2 was again scheduled. Now process P2 if again scheduled, can it allow you into the enter into the critical session? No. Again, it will be in the busy waiting only. It will still execute your entry session. Now, let's take that process P2 was preempted. Again, process P3 was scheduled and it will execute the critical session and execute the exit part. So, it will come out from the critical session. So, it is executed the exit session. Okay. Now, there is no process in the critical session. Now critical session is vacant. Now process P4 was scheduled. Now process P4 is scheduled and it wants to enter into the critical session. As the critical session is vacant, it will enter into the critical session. Now process P2 again scheduled. Now can it enter into the critical session? No, it will be in the waiting. So in this situation, what is happening? Process P2 is keep on waiting. Is it clear? When it will get the chance, we cannot say. If it is other process are scheduled, whenever there is a critical session is vacant, then process P2 will be in the waiting state. So meaning is that bounded wait is not provided in the test and set instruction. And coming to the portability, what is meant by portability? Whatever the synchronization mechanism we have designed, it should work in all the hardwares and all the operating system. Am I right? If it is hardware based support, it should support in all the hardware platforms, and if it is a software mechanism, it should work in all the operating system. But this test and set is a separate instruction. Am I right? If your hardware supports, then only this synchronization mechanism will work. If your hardware does not support this instruction, then we cannot execute this process synchronization mechanism. So even it is not portable. I hope you have understood what is the test and set instruction and what is its limitation. Now let me discuss one more limitation in the process synchronization mechanism, which we will call test pin lock. Okay, I know that the video is lengthy, but I want to discuss all the important points related to the test and set instruction. Is it clear? I have erased this one, but I want to keep it. If I erased it also, no problem. Okay, let's consider that process P1 and process P2 is there. Let's consider process P1 is there right now. Its priority value is 1. Okay, we are running the priority based scheduling mechanism. Is it clear? Now let's take the process P1 is in the running state and its priority value is 1. So right now critical session is vacant. Now if critical session is vacant, now it will execute the entry session and it can enter into the critical session. Now process P1 is in the critical session. Now when the process P1 is in the critical session in the ready state, process P2 has arrived and with priority value is 2. Now look at the priority value. Process P1 has the priority value 1 and process P2 is having the priority value 2, and you are running a preemptive priority based scheduling mechanism. Meaning is that if any high priority process is there in the ready state, if the process which is running have the less priority, then it will be preempted. So if we look at the situation, process P1 is in the running state and it has the low priority as compared to the process which is there in the ready state. Is it clear? So process P1 has been preempted. Now in the critical session, process P1 is there. Now P2 want to enter into the critical session. It is now in the running state. Can the process P2 enter into the critical session? No, it is waiting. Now look at here. Unless until process P2 complete its task, P1 cannot enter, because if high priority process is there in the running state, then the process which are there in the ready state has to wait. Now process P2 cannot complete its task, because once it completes the critical session, then only it can execute the exit session, but it is still there in the entry session because process P1 was there in the critical session. Is it clear? So now what I want to say is that critical session is with the process P1 and CPU with the process P2. Am I right? Is it is a deadlock? No. Why? If both the process are in the waiting state, then only we will say that a deadlock. Is it clear? Process P1 needs some resource, then only it can complete the task. And process P2 also needs some instruction, then only it can complete the task. Am I right or wrong? In this case, both the processes are there in the waiting state, then only we will say that there is a deadlock. Is it clear? But here one process is there in the ready state. Process P1 is there in the ready state. Process P2 is in the running state. So this is not a deadlock. This is what we'll call spin lock. So in priority based mechanisms, okay, in preemptive priority based scheduling mechanism, this test and set instruction will not work. I hope you have understood all the concepts related to the test and set instruction. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.